Ever wonder why a fast-moving car causes more damage in a crash than a slow one? Or why kicking a soccer ball with more force sends it flying farther? The answer lies in momentum and impulse, two key concepts that explain how things move and how they stop. These forces are all around us, shaping the way objects interact every day. Welcome back to Science Bites. Today, we're diving into momentum and impulse to show how they work together to affect the world around us. Let's start with momentum. Momentum is the product of an object's mass and velocity. The more mass an object has, or the faster it's moving, the more momentum it carries. Think about a train speeding along the tracks. Its size and speed give it tremendous momentum, which makes it difficult to stop quickly. Compare that to a soccer ball. Small, light, and easy to stop, but still capable of moving fast when kicked with enough force. Momentum is what makes it harder to stop larger, faster objects. Next, we have impulse. Impulse is the change in momentum, and it's caused by applying a force over a period of time. The harder or longer you apply a force, the greater the impulse. Imagine hitting a nail with a hammer. A fast, strong swing delivers a bigger impulse, driving the nail deeper into the wood. The same concept applies when braking a car. The longer you apply the brake, the greater the impulse, which slows the car down. In both cases, impulse is changing the momentum of the object. In real life, momentum and impulse play critical roles in safety. In a car crash, a fast-moving vehicle has high momentum, which can cause serious damage. That's where airbags come in. When a crash occurs, airbags increase the time over which the force is applied, reducing the impulse and decreasing the impact on passengers. By spreading out the force, airbags help prevent injury, proving how impulse management can save lives. Sports are another great example of momentum and impulse in action. Think about catching a fast-moving basketball. You don't just grab it, you cushion it by moving your hands backward, spreading the force over a longer time, reducing the impulse. Or when hitting a baseball, you want to apply as much force as possible in a short time to transfer maximum momentum to the ball and send it flying. So next time you see a fast-moving object or feel the force of a powerful impact, remember momentum and impulse are at play. From car crashes to soccer kicks, every movement and collision involves these two forces. Next time on, we'll explore the difference between speed, velocity, and acceleration. What really makes a car go faster, and how do we measure it? Stay tuned. Like and subscribe for more bite-sized science that makes the universe easier to understand, one concept at a time.